Okay, so today we are reviewing SOHCAHTOA. I'm hoping that sounds familiar. Some of you had me for math too, and remember that, yeah. So we're looking at the first three fundamental trig functions. Trig functions define the relationship between the size of an angle and the length of two sides of a triangle, specifically a right triangle. This is true even for the unit circle, because essentially the unit circle is a bunch of right triangles formed by the x and the y components. So we're going to review some vocab, the anatomy of our right triangle. Right triangles have right angles. How big are right angles? 90 degrees, very good. Or we are going to use another unit of measure for angles. What else can we measure angles in? Does anybody remember? Radians. I think you're thinking radians. 180 is flat line. The other units. So we have degrees, 90, 180, 270, 360, or radians. And 90 degrees is pi over 2 radians. I don't expect you remember that right now, but we are going to see that end of this week, starting next week. In this picture, my right angle is angle A. Yeah. We define the sides of the triangle based on where they sit relative to that 90 degrees. Two of those sides are the sides that make the 90 degrees. Those sides are called the legs of the triangle. So this is a leg, and this is a leg. So the legs are the two sides that form the 90 degrees. So in this picture, AC and AB are the legs of my triangle. There's one side we have not labeled. That's the side opposite the 90 degrees. Very good, Jesus. That is called the hypotenuse. Thank the Greeks for the funny names, hypotenuse. And in right triangles, the hypotenuse is also going to be the longest side. If you are solving for the lengths of sides at a right triangle and one of the legs turns out longer than the hypotenuse, you made a boo-boo somewhere. Hypotenuse should always be the longest because it is opposite the biggest angle. This is my widest angle. The side opposite should be the longest side. The shortest side should be opposite the smallest angle. So in our triangle, line BC, line segment BC is our hypotenuse. Can I get a thumbs up if those words sound vaguely familiar? I see thumbs up and hell yes, and smiles. Yay! Very good. The hope is that the next chunk is also familiar, which is the three primary trig functions you learned about in Math 2 were sine, cosine, and tangent. Sin, cos, and tan, yeah? And you learned the acronym SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Yeah? We're going to define opposite and adjacent just to make sure we're clear on what those words mean. when we are talking about the opposite leg, we are talking about, whoa, how did that happen? No, go back. Go back, there we go. We are talking about the leg that is across from the angle of interest. I'm going to use theta for our angle because that's the common symbol for a missing angle. Theta. Theta is the symbol for an unknown angle. Most common. You will notice we typically use English letters for things like points and lines, and we use Greek letters for angle measures. And you will see that pattern all throughout this semester. If opposite is across from the angle, what do we think adjacent means? In words that are more understandable than adjacent. Next to, very good. Next to or touching, yeah. I'm going to go back up to our picture here. We know where our hypotenuse is. But given this angle down here, angle B, which side is opposite and which side is adjacent? So I'm going to give you about 30 seconds in your small group. Discuss relative to angle B, which side is opposite, which side is adjacent. 30 seconds. You got the tape off and everything? Yes. These ones. Okay. Yeah, that's going to be hard to not rip the elbow off. Okay, we'll leave the tape on. Ah, the shoes, the shoes. I know. Thank you. Okay, who can I pick on? Who can I pick on? She is not here, frowny face. Anela, looking at that picture, which side is opposite angle theta? AC, very good. It is across from angle theta. Very good. Hey, Seuss, where is my adjacent side? AB, very good. In general, when you are solving right triangle trig problems, you draw the right triangle, you label the angle of interest, like I did here in blue, and then you label the sides, opposite side, adjacent side, hypotenuse. Those three labels should not overlap. For any angle in the triangle, that's not the right angle. There's one adjacent side, one opposite side, one hypotenuse. Yeah? Good. Okay. Scoot you down here. We have an example to practice setting up those trig ratios, SOHCAHTOA. So we're shown a right triangle here, ABC, and we're asked to set up the ratios for sine, cosine, and tangent for angle beta, down here, angle B, That's these guys here. And then for angle gamma, which is this guy up here. Yeah? I am going to put about 5 minutes on the clock. I would like you to set up those fractions. SOHCAHTOA. Alexis, can you walk me through what those trig ratios are for angle beta? Can I get a thumbs up if you agree with Alexis's fractions? I see thumbs up popping around the room. Very good. Looking at blue, the opposite side is 4, the adjacent side is 3, the hypotenuse is 5. Those match up. Very good. Let's see who's next. Oh, we got another absent person. Let's try again. All right, Estrella. What'd you get for angle C, angle gamma? So 3/5, and then for cosine? 4/5, and then tangent? 3/4. Can I get a thumbs up if you agree? Thumbs up. Very good. What do we notice about the relationship between the trig functions for angle beta and the trig functions for angle gamma? Same hypotenuse, so the bottom of those first two fractions is the same. What else do we notice? Sine and cosine switch. Yep, these guys switch. Good. What about with tangent? They flip. Yeah, they're reciprocals. The numerator and denominator flip. Yeah, good. Because the roles of opposite and adjacent flip. Very good. The hypotenuse will always be the same. That denominator for sine and cosine should be the same for every fraction that comes from that triangle. Hypotenuse is fixed. It's always opposite the 90. But whether I'm down here or up here changes which one is adjacent, which one is opposite. Good. Very good. A reminder, if you want to get started on your delta math, because you've got about 20 minutes of class time to do so. If you are asked for an exact answer, reduce. If you don't know how to reduce the fraction, you can use your calculator. Divide the top by the bottom and then go math frac, and it'll turn it back into a reduced fraction. Yeah? You've got about 20 minutes to get started on week 1 homework. If you have questions, let me know. We will pick up with notes 1, going over all 6 trig functions and their properties when I see you tomorrow. Yeah.